Imagine a sound that isn't really there. It's a kind of relentless ringing or maybe buzzing, sometimes a hiss, just inside your head. For millions of people around the globe, that's not imagination. It's the daily reality of tinnitus.
Yeah, it's incredibly common. We're talking maybe 10 to 15% of the population worldwide.
Wow. And it's not just, annoying background noise, is it? It can seriously impact life.
No, absolutely. It can disrupt sleep, make it hard to concentrate, and for some people, it leads to quite severe psychological distress.
And despite being so widespread, finding really effective treatments that actually work consistently, well, that's been a real challenge.
It really has. And part of that challenge is just how complex tinnitus seems to be at the brain level. We're still figuring out all the mechanisms. What we do know is it seems deeply connected to an imbalance, in certain brain networks.
Okay.
And sometimes, interestingly, it's linked to what we call hidden hearing loss.
Hidden hearing loss. What does that mean exactly?
Well, these are often subtle issues, maybe in the inner ear, the cochlea, sometimes called dead regions. Traditional hearing tests might miss them because they don't always affect your basic hearing threshold for everyday sounds.
But they can still contribute to that phantom noise.
Exactly. They can definitely be a factor in generating that internal sound.
So, given it's such a tough nut to crack, with these complexities, where do we even look for relief?
Well, that brings us to our topic for this deep dive.
Right. We're looking at something called transcutaneous auricular vagus nerve stimulation. Bit of a mouthful.
It is. taVNS for short.
taVNS. Okay. So our mission today is really to unpack what this is, how scientists think it might actually work on the brain, and crucially, what the latest research says. Does it hold real promise?
We'll try to cut through the noise, so to speak.
Give you the clearest picture possible on this emerging approach. Okay, so you mentioned brain networks being out of balance. That sounds a bit like the brain kind of rewiring itself, but in a bad way.
That's a great way to put it. For many types of tinnitus, we talk about maladaptive plasticity in the central auditory system.
Maladaptive plasticity.
Yeah, essentially the brain's sound map gets distorted, and that seems to create these phantom signals.
So the brain learns the wrong thing almost.
In a sense, yes. And this is where vagus nerve stimulation, or VNS, and taVNS is a type of VNS comes into play. It's a neuromodulation technique.
Neuromodulation, meaning changing how nerves work.
Exactly. The idea is that it triggers the release of specific brain chemicals, neuromodulators, things like acetylcholine, norepinephrine, serotonin, and BDNF, brain-derived neurotrophic factor.
Okay, and those chemicals are important.
Critically important. They are absolutely key for enhancing the brain's ability to change and adapt its plasticity.
So it's not just stimulating the nerve for the sake of it, it's stimulating it to release these specific chemicals.
Precisely.
That then help the brain basically, relearn or normalize itself.
That's the concept. It's like giving the brain the tools it needs to potentially overwrite that faulty tinnitus signal.
That feels like a really different way of thinking about treating something often seen as permanent, targeted plasticity almost.
It is. There's a useful analogy sometimes used comparing it to vaccination.
Oh, how so?
Well, think of the VNS as an adjuvant, something that boosts the immune response in a vaccine.
Right.
And the specific experience, maybe listening to certain sounds, acts like the antigen. Neither one alone causes a really strong, lasting change.
Right.
But put them together, and they can synergistically drive specific, long-lasting changes in those neural circuits.
So VNS primes the brain, and the experience directs the change.
That's the theory. It works because VNS activates these central vagal pathways. About 80% of the vagus nerve fibers go up to a place called the nucleus tractus solitarius, the NTS, in the brainstem.
A relay station.
Kind of, yeah. And from the NTS, signals travel on to other really important areas like the locus coeruleus and the brachynuclei.
And those areas do what?
They're major sources of those neuromodulators we mentioned, like norepinephrine and serotonin. They influence alertness, attention, mood. Key factors for learning and brain plasticity.
So stimulating the vagus nerve is like using a master key to unlock the brain's change mechanisms in these very specific, powerful centers.
That's a good way to visualize it.
Okay, that mechanism sounds powerful. But invasive VNS involves surgery, right? Implanting a device.
Traditionally, yes. For epilepsy or depression, that's often the case.
But taVNS, the T and AA stand for Transcutaneous Auricular, meaning through the skin on the ear.
Exactly. That's the key advantage here. taVNS is non-invasive. Electrical stimulation is applied to the auricular branch of the vagus nerve, the ABVN.
And that branch is just Right there on the outer ear.
It is conveniently located in specific parts of the external ear. You can actually reach it from the surface.
Which ear? Does it matter?
Typically, it's done on the left ear.
Why the left?
Mainly to minimize any potential risk, however small, of affecting heart rhythm. The right vagus nerve has more direct influence on the heart's pacemaker. Standard VNS protocols usually favor the left side for safety.
Makes sense. Still, it seems kind of amazing that just stimulating the skin on the ear can reach those deep brain areas you mentioned, like the NTS and locus coeruleus.
It does seem remarkable, but we actually have evidence it works. fMRI studies, brain imaging studies have shown that taVNS activates those same central pathways.
Really? So the signal gets through?
It appears so. The NTS, the locus coeruleus, the brachynuclei, they show increased activity during taVNS, similar to what you see with invasive VNS.
Okay, so where exactly on the ear do they stimulate? Is it just anywhere?
No, it's quite specific. The tragus, that little flap of cartilage in front of the ear canal, is a very common site used internationally.
Okay, I can picture that.
In China, they often use a spot called the cavitas conchae, which is sort of the deeper bowl-shaped part of the outer ear.
Is one better than the other?
Well, the tragus is generally easier to place an electrode on consistently. But some research suggests another spot, the Simba conchae, kind of a specific hollow above the main bowl, might activate the vagal pathway a bit more effectively.
Why wouldn't that be?
Possibly a higher density of those vagus nerve fibers there. It might also tolerate slightly higher stimulation intensity before becoming uncomfortable, which could lead to stronger brain activation.
Interesting. So placement matters.
Yeah.
What about using something like the earlobe as a comparison, a sham?
That's been done in studies using the earlobe as a sham or placebo stimulation site. But interestingly, some studies found that even earlobe stimulation activated some brain regions.
So maybe not a perfectly inert control.
Potentially not, yeah. It complicates interpreting results sometimes if your placebo isn't truly inactive.
Right. And what about the actual stimulation itself, the settings? Is it like a strong shock or?
Oh no, definitely not. While the optimal parameters are still an active area of research, studies often use frequencies around 25 hertz with very short pulses like 250 or 500 microseconds. And the intensity is key. It's usually set at the highest level that's comfortable for the person, just below the point where it feels painful, like a tingling or pulsing sensation.
So noticeable, but not unpleasant.
Ideally, yes. And it's really important to stress that the amount of current used for this kind of targeted plasticity VNS is much lower, maybe up to 100 times less than what's used in the approved protocols for epilepsy or depression.
Okay, that's reassuring. Suggests it should be pretty well tolerated and safe in this context.
That's the general finding, yes. Safety profiles in most taVNS studies for various conditions have been quite good.
Okay, so the mechanism is plausible, the non-invasive approach is appealing, safety seems reasonable. Let's get to the big question. Does it actually work for reducing tinnitus? What does the clinical research show?
Right, the million-dollar question. And this is where things get, well, a bit more complex. There are mainly two ways researchers have approached using taVNS for tinnitus.
Okay, what's the first one?
The first is pairing taVNS with sound stimulation.
Like that vaccination analogy you mentioned earlier. The VNS as the adjuvant, the sound as the antigen.
Exactly. This approach comes from some really interesting animal research back in 2011. They showed that in rats with induced tinnitus, pairing VNS with tones, specifically tones other than the tinnitus frequency, could actually reverse the brain changes associated with tinnitus.
Wow, reverse the changes.
According to that study, yes. And the benefits reportedly lasted up to 3 months.
That sounds huge. Any caveats?
Well, a significant one is that, as far as I know, this specific, quite striking animal result hasn't yet been independently replicated by other labs, which is always important in science.
Right, replication is key. What about in humans using this paired approach?
In humans, there have been some studies, often uncontrolled initially, using taVNS paired with something called tailor-made notched music training.
Notched music.
Yeah, where they take music and digitally filter out the specific frequency range of the person's tinnitus. The idea is you listen to this modified music while getting the taVNS.
Okay, and did that help?
Some of those studies reported significant reductions in subjective loudness, how annoying the tinnitus was, and scores on the Tinnitus Handicap Inventory, or THI, which measures real-world impact. They also saw some corresponding changes in brain activity, like a reduction in gamma band activity, which has been linked to tinnitus loudness.
Any controlled trials of this paired approach?
There was one randomized double-blind trial, the gold standard design. It found a significant improvement in THI scores in about 50% of the group getting the active taVNS paired with sound, compared to only 28% in the control group.
So better than placebo, but maybe not a slam dunk for everyone. And was the sample size big?
That's a fair summary. And no, the sample size in that particular trial was relatively small, which limits how firm the conclusions can be. Okay, so that's the paired approach. The second main line of research is looking at taVNS alone without combining it with specific sounds.
Just the nerve stimulation itself. How does that fare?
Here, the evidence is decidedly more mixed. Some studies, even running for 24 weeks, found basically no clinically relevant improvement in the tinnitus symptoms themselves, the perceived sound.
That's disappointing.
It can be. However, it's not the whole story. Other studies did suggest that taVNS alone can be helpful for the other stuff that comes with tinnitus, the mental stress, the anxiety, the overall handicap it causes.
How would it help with that, if not the sound itself?
These studies often showed improvements in measures of parasympathetic nervous system function, like heart rate variability.
Okay, heart rate variability. That's a marker of stress resilience, right?
Exactly. So the idea is that taVNS might be helping regulate the body's stress response, calming the system down, which indirectly lessens the burden of the tinnitus, even if the sound persists.
So it might help you cope better, even if the ringing doesn't stop.
That seems to be a possibility suggested by some research. But there's another complication here. In some of these studies where they saw benefits for stress or coping, the taVNS was actually given alongside other therapies, like tinnitus retraining therapy or TRT.
So it's hard to know if it was the taVNS, the TRT, or the combination?
Precisely. It makes it difficult to isolate the specific effect of the taVNS itself, and we also have to acknowledge the placebo effect.
Right. Always a factor.
Absolutely. Some trials have noted quite a significant placebo response where people getting the sham stimulation also reported improvements.
Okay, so putting it all together, it feels like the jury is still out, wouldn't you say?
Yeah.
It's not a clear yes or no yet.
I think that's a very fair assessment. What really stands out is that taVNS shows definite promise, especially, I think, as a potential add-on therapy.
For tackling those related symptoms, you mean? Like the anxiety, the sleep problems, the depression that often accompany tinnitus.
Exactly. Those can be just as debilitating, sometimes more so than the sound itself. Helping with those is a significant benefit.
But the direct evidence, the hard proof that taVNS by itself can reliably reduce or eliminate the actual tinnitus sound, that's still lacking.
The evidence for that specific outcome isn't robust yet. Many of the studies we have, while valuable starting points, have limitations.
Like the small sample sizes you mentioned.
Yes, small sample sizes are common. Also, a lack of really good control groups. In some studies, it's hard to rule out placebo or other non-specific effects without a well-designed sham condition.
And follow-up. Do we know if any benefits last?
Insufficient long-term follow-up is another common issue. We need to know if effects persist weeks or months after treatment stops.
So if someone listening is looking into tinnitus treatments, it sounds like being aware of these study details, sample size, control groups, follow-up is really important for evaluating claims.
Absolutely critical. It helps you understand the strength of the evidence behind any new therapy.
So given these limitations and mixed results, what's next? Where does the research on taVNS for tinnitus need to go to get clearer answers?
Well, the most urgent need is for more high-quality clinical trials. We need studies that are designed better and are larger.
Bigger sample sizes, obviously.
Definitely. Larger numbers give us more statistical power to see real effects, and we need really well-thought-out control groups.
Better than just stimulating the earlobe, maybe.
Yes. For instance, stimulating a different nerve in the ear, like the great auricular nerve, which isn't part of the vagus pathway, that could help clarify if the benefits are truly specific to vagal stimulation, or if it's just stimulating something in the ear or purely placebo.
That makes sense. Isolate the variable.
Exactly. We also need to incorporate more objective measures, not just rely on subjective reports of symptoms.
Like the brain imaging you mentioned, fMRI.
Yes, fMRI, to see brain activity changes directly. Also things like EEG measures, perhaps looking at specific brain waves like the P300 component, which tells us about how the brain processes unexpected or relevant sounds.
And maybe stress markers.
Right. Physiological markers like salivary alpha amylase, which reflect stress levels. Combining subjective reports with these objective biological markers would give us a much fuller picture.
Anything else needed in future trials?
I think it's also really important to start categorizing patients better. Tinnitus isn't just one thing.
You mean like whether it's new onset versus chronic?
Exactly. Acute, subacute, chronic tinnitus might respond differently.